and I'll have to get that uploaded at some point. All right. So now that we're recording, I'm just going to say for the benefit of the recording that we covered some things around the discussion forums and maybe some things for us to try. But what we're going to do here is we're going to bring up lesson 3, or sorry, unit 3, and I should be able to share this. Give me a moment. Somebody want to confirm you can see this?
Yeah, I can see it.
Okay, great. Thank you. Thank you. So this looks different because I'm in instructor mode versus student mode, so it may look different, but the reality is it's going to still be the same content here. So let's go to lesson 4 and maybe spend a moment there. So, you know, some of you may be whipping through the non-programming pieces of the lesson and going straight to the programming. Some of you may be making sure you're covering all of this. I do recommend that you spend some time, of course, on the other content other than the programming. One of the traps that a student could fall into is, well, I know how to program, but I don't understand enough about the computer hardware, or I don't understand enough about the trade-offs. And you find yourself a pretty competent programmer without knowing some of the tricks and the limitations. So it's really useful to make sure you get enough of that other computer architecture or computer organization knowledge. And that's what I think one reason why CS160 is a good class, because we try to do both equally. Okay, so so here's an example of the REPL IT, or the Replit app that we're using. This, by the way, is not the only way that you can develop in Python. There are other development environments that you can use. What's cool about this is you can do it right in the web browser, right? And so we could take this program here, and we can click run, and we can follow what is one of the other instructors, what she did with this program here. We have a little bit of ability to kind of move the windows around, but not much here. A few things that by the time we've gotten to this lesson that we've talked about already around Python. One important point is indentation matters, right? And when we get to conditionals, I'll show you what that means if you haven't done that yet. Indentation matters. Another thing that's important about Python is the concept of variables and data types. If you look here, we have 2 different variables. We have a variable that's called name and a variable that's called age. They have 2 different types of data. And in some programming languages, you have to actually specify the type of data you want for a variable. So in C++, for example, you would actually have to say that the variable age would be considered an integer. In computer programming, an integer is the same thing as a whole number. So you think of whole numbers in math, and integer is the same thing. Although an integer may be limited. Whole numbers go up from -infinity to +infinity. An integer is usually limited by the size of the number of bits that were allowed. Now, if I take this age 20 and I put, oh crap, sorry. I did this. Sorry, give me one sec. I gotta. I have to see if I've already done this or just use my personal one. Okay. Sorry about that. All right, let's try this again. Okay, so if I put these tick marks around the 20, something changed. What did you notice changed as I put the tick marks around the 20?
The color changes, obviously, from
The
green
color
to red.
changed. And so why do you think that? Why do you think the color changed?
It's a string.
It's considered a string instead of an integer. Now, if I run this, I get the same output, right? Because if I print 20 as an integer or I print 20 as a string, it's still the same thing. But what happens if I try to do this? If I try to add 1 to age, do you think it'll work?
No.
Yeah, I do.
Okay.
I think it will, but it will just maybe concatenate it.
Yeah, so we get a bunch of different answers here. So we'll try it. This is a good thing about it is we just try it, right? What's the worst that's going to happen, right? It's going to give us the traceback error. That's the worst. Basically, unless you're like writing to files and you run the risk of like deleting things, the worst thing that's going to happen to you is you're going to get these ugly error messages, right?
Right.
So depending on the language, by the way, all 3 of those answers are correct. Right? I could pick a language where it would print 21, and I would pick a language where it would print 201, and I would pick a language where I get an error. And in Python, we get an error, right? And it says that I can only concatenate strings to strings. So in other words, the plus sign here, Python is treating that as what's called a concatenation operator. And a concatenation in programming means putting 2 things and just connecting them together. So if I can concatenate AB to CD, I get ABCD. Does that make sense?
Quick question. Would that be the same for like, so they basically have to say the same, right? String to string or integer to integer?
Generally, yes.
Okay.
Okay, so let's come back to this in a second. So I can just put a couple, 1 or 2 pound signs in front of this to comment this line out. So now when I run it, I'll be okay. But now let's do this. So now if I do this, what do you think will get printed? Any ideas?
Jeff Abramson?
Is there a space between the Jeff and the Abramson?
No.
No.
Let's see. Okay, you're right. So I could do it instead. I can do it this way. Right, and I think we can, now it'll print, last name, comma, first name. So using the pluses when you're operating on strings act as concatenations. So very often you are going to want to manipulate strings. And you can manipulate strings using concatenation or other functions. But now you can see here's where I'm operating on the integer data types by adding 1 to it. Let's say that age is indeed a string. And I want to do numerical analysis to it. What I have to do is I have to convert it to an integer. And you can do that simply by putting the variable name inside this function called int. So now it works. What it does is it takes age, which is a string, converts it into an integer, adds 1 to it. This expression is still an integer. And so age now it's holding an integer instead of a string. Has anybody in the group here programmed in another programming language before? Java, C++, Perl, anything?
No, this is my first
No.
time ever doing anything.
Okay. This is the type of thing that if you're an experienced programmer in other languages, like just throw you for a loop and can throw you for a loop. And actually, when I think about all the programming languages I've programmed in, Python is actually the one that's newest to me. And And this is the kind of stuff that you kind of had to unlearn things to learn things. And so the key point here is data type does matter, even though you don't need to specify your data types. And so if we were to add to this program and we were to add some input to this program, and this is where this type of thing will trip some of you up, certainly when you're doing your programming, which there's a lesson later where you learn the input command, right?
I don't think I've gotten there yet.
Okay.
I think
so
it's
we're gonna-
10.
10. Okay, we're going to jump around here. So this, so we're going to say name equals input. Let's see. I want to do this. How do I want to do this? Let me have some notes here. Let me check. We might just go to the lesson. Maybe we'll just go to the lesson. Let's just go to the lesson. Lesson 10. Okay. Yeah. Okay. That is what I wanted to do. So let's say we wanted to change this program. So instead of hard coding the name as a variable, we want to ask the user for their name. So we can say name equals input, enter your name. And one thing you can note here is that I put a space right here. This is a kind of a user experience like thing. So let me run this and show you. So you can see here that the cursor here and where I type something, there's a space after the colon. I do see a lot of submissions where somebody does this. I don't consider this a good user experience, right? And so, because as soon as I start to enter my name or I start to enter one of your names, it's like there's no, does that mean I have to type a space or do I need to hit return or something like that? So I would always recommend that you give yourself a delimiter. So now when we run this program, we're going to be able to type in whatever we want. Type in whatever I want, and it's going to assign it to that variable, right? So the variable gets assigned to the result of this function or this expression. Okay, now a common problem that I see in these programs is, let's change this to from a name to a number in percentage. So now if we do this, we enter our percentage and we just do 20, it's going to print that out. But if I say, now we'll say item price equals input. Enter this is sales tax. Enter the price of the item. Okay, if I want to calculate the total based on the sales tax and the item price, how do I do that? You walk
Item
up to,
price.
go
Would
ahead.
it be-
Barry.
Would it be item price plus tax?
You got to calculate the tax. We have the tax rate. So, but we have to calculate the tax to add it to the item price. So you go to somewhere outside the state of Oregon and buy something, right? and Seattle, here in Seattle, our sales tax is about 10%. So let's call our sales tax 10%. You know, if I buy
So we'd have to multiply it. I just don't know how to write that.
Okay, well, keep
Okay.
thinking it through. Say what you think the algorithm is, right?
think
Because this is
item-
about, this
So-
is about forming that, right?
Yeah, so it'd be item price times tax rate would equal your total price.
So we do item price times tax, is that what you said?
Yeah,
Then you have to add the item price again.
Like that?
Yes.
Let's try that. Okay, we'll do some easy numbers. 10% sales tax of an item that cost 100, we get a stack trace. Okay, so we look at our stack trace here and it says can't multiply a non-int, right? You can't multiply something that's a string. Okay, so
so we would have to do INT.
that's right. And the best place to do that would be to put it around here.
Okay.
Right? So you can, I'm going to show you two different ways to do it, right? You could do it all in the same function. Or you can get the item price and then you can turn it into an int. So either option on line 3 or the option on 4 or 5 are both equally good. This is an important point around programming, is this ability to like do what's called nested functions. Right? So the input function returns something, and then you immediately send it through the int function before you assign a variable to it. The downside of nesting things like this is that if there's a problem, it's harder to debug, and you may end up separating things to debug it.
Mhm.
Okay, so now let's run it. Let's try this. Okay, so we still got, oh, I have a typo. Where's my typo? Right there. Okay. Should have paid attention. No, it doesn't show me. Okay. Let's try it again. Okay, there is a wrong answer. I see what I did wrong. What did I do wrong?
You kept the, I don't know.
Well, the tax needs to be put as a decimal.
Yeah. So how do I do that? How do I change since I type in 20, because I say in percentage, I could have asked you to just say 0.1, but you think about your users, right? Let's say that, you're writing an app, for users at a bar or restaurant, and the bartender to enter the tax. The bartender, she or he is going to want to say 10%, not 0.1, right?
Right.
So what do we do to basically to fix that?
Use the format function.
Well, formatting is about displaying, right? So right now, the tax that's been entered is actually 10.
So we have to like make tax a decimal by making a new rule.
Could you do tax multiply by 0.1 or 0.01?
Okay,
Let's see.
which one do you think?
0.01.
Okay, so so let's try this here. We're going to try this here. So tax A is equal to tax times 0.01. I think that's what you said, right?
Yes.
So let's try that. Let's see if that gives us what we want. That's good. That's what we wanted, right? We can do tax B is equal to tax divided by 100. Same thing, right? Those two mathematical things do the exact same thing, right?
Right.
So this becomes a preference then, right? Right, same answer. So because tax was entered as a percentage, to convert a percentage into its base number, you got to divide by 100 or multiply by 0.01.
Now,
And then
quick
what you
question.
also may have noticed here is when we printed this out, it actually printed the values out here with a 0.0 on here. Before we did that, it was just a 1010 without a decimal point. And that's because both of these calculations turned the tax result, it turned it in from an int, it turned it into what's called a floating point variable.
Right.
And a floating point variable is more akin to the real number space in mathematics, where integers are akin to the whole number space in mathematics.
Will it do that automatically, or do we need to account for that at some point?
Well, it did it automatically here. So so even though my result is not fractional, it did it. So by dividing by 100, it just automatically did that. Now let's say that I want to print this out in normal currency form, right? I could put a $ there, but how do I print this so I get 2 digits after the decimal? Does anybody know how to do that?
That's where you use the format.
Okay.
So you do format, and then in parentheses, it's total, comma, a single quotation, 0.2f. I think that's right.
If you noticed, once I did the first tick or the single quotation, it did the second one for me, but it didn't automatically add the parentheses. So it's this kind of stuff you got to watch for, right? So if I forgot to do the parenthesis, it's going to complain, right? It's going to basically say I have an invalid syntax. And what happened is it got to this line before it resolved the previous one. This is a tricky error message, right? Because if you look at just the error message, it says, hey, line 13 has an error message, which is main, and you're saying, hey, I didn't touch that. I didn't change line 13. What is going on? And so typically when you get an error message that points you to a line that looks good, you got to start working your way up, right? And in this case, we're missing a parenthesis. Some programming language environments are better at this than others. I think Visual Studio, which you'll learn in CS161 and you'll program in C++, will give you a better job, will do a better job of pointing out this error message. So there we go. So nice job. If you had asked me that format command, I would have had to look it up. It's not a natural one for me. So this basically is saying that I want to use the floating point format with 2 digits after the decimal point. And of course, I put the $ manually in front. Now let's try this with like a different number. So let's say our sales tax is 3.33%. Oops, what did I do wrong? Oh, it's an integer. Yeah. So that's a good point. Let's go through this here. If I enter a tax rate of 4.5, I get an error message because I'm setting it to an int here.
So if you change that to float, would it work?
Let's try. Now we get to our price, and our price is still an integer. So let's stick to we'll pick a weird number. And then we get, that looks about right, $27 plus about 4.5%. So Python is actually pretty good that it will catch bad input. And this is something that you'll hear as a theme from me about the concept of bad input versus illegal input. Okay, so I'm sorry, somebody say something, I missed it.
Oh, sorry, I wasn't on mute.
Okay, no problem. So if I think about illegal input is when I enter a string when I want an integer, or when I enter an integer or a float when I want an integer. If I want a float and I enter an integer, it's okay. Because if I enter 4, that's just 4.0, but it can't work the other way. Those are examples of illegal input or bad input. There's other cases of errors where the input is still valid, but it's not allowed. And an example of that would be taking the square root of a negative number, for example, or trying to divide by 0, right? Where it's not about the data being in the wrong data type. It's about the value of the data can't be the value of the data. And you have to check for that kind of stuff as well.
So would you recommend that we just by default always use float when we're dealing with like numbers like this?
The answer is to these types of questions is always it depends. I would say no. Any thoughts as to why? Like you could have all your variables always be floats, your numbereds, right? So that you never have this problem, right? Why is that? Why might that not be a good idea?
Maybe your program will never have a number that has decimals in it for some reason.
But it would still work though, right?
It would still work.
Right. So I think the question was, to be safe, why not do that?
Right.
And you're saying, well, if the program doesn't need it, why do it? Right. And that's a good point. But any other thoughts about why it might be not the best idea? It's early in the class to have this conversation. I'm just curious if anybody's thought about this.
Wouldn't it require like more system resources if
Yeah.
it's always calculating like so many floats, like to
Yep.
is it the software like Python might be calculating more floating positions than we're actually displaying. So we're displaying 2, but it might be thinking much more.
Okay. So
in
just
depth.
takes up too much data.
Yep. Yeah, that's right. So that's good. That's very good. So an integer takes 32 bits unless it's a long integer, and then it takes 64 or more depending on the language. So a 32-bit integer lets you store a number between -2 billion and +2 billion approximately. So as long as all your numbers are within that range, you can use ints to your heart content. If you use floats, double precision floats, they take 64 bits, sometimes more, 80 bits, sometimes more bits of data. More importantly, the calculations take longer to run on the hardware. We don't spend a lot of time talking about the actual guts of a microprocessor in this class. And if you take CS201, you'll dive into it a little bit more. And of course, if you transfer into a computer engineering curriculum, at Oregon State or somewhere like that, and you take a computer architecture class, you'll get really deep into it. But if you bear with me for a second, my first job out of college, I was a chip designer, and I went to work for Intel in Hillsboro, right? So I moved out to Oregon and was working at Intel, and the first chip that I worked on was the Pentium Pro processor, which came out in 1994. We designed the circuitry to optimize around how fast you could do a 32-bit add. In other words, the clock speeds of the chip, the memory bandwidth, the sizes of different buffers, so many different constraints were all based on how fast could the circuitry do a 32-bit add. And so when you're doing a lot of number crunching, right, which in this program we're not, and any program you write for these classes, it's really not going to matter practically. But in production programs, it is almost always faster, cheaper, and smaller to operate in ints versus floats. And so you want to be careful when you're using floats, and you want to use them with discretion. And so, in fact, there's a lot of programmers, what they do is, if you're doing financial related software, instead of doing the stuff like this and using floats, you just do all your calculations in pennies. And you just have integer numbers of pennies, and then you display the data in a different way. If you think about that, right? If we're making change at a cash register, you could do the math in dollars, or you can do the math in pennies. If you do the math in pennies, it's all integers. If you do the math in dollars, it's all floating point, right? So
could you show us a quick example of how we would do something like that? Like how would we keep everything in like pennies versus dollars? Like,
Okay, so let's do that, right? So we're gonna go back to, okay, so we're gonna say item price in pennies equals item price times 1,000.
1,000 or 100?
Sorry, I said 1,000, but I wrote 100. Thank you. So there's our conversion. Now, if I want to manipulate this, right? So I took the tax rate out, but let's put some tax back in. Let's say the tax is 10%.
Tax times item price in pennies.
Right. So if we compute the total with tax in pennies, that's going to be item price in pennies times, I don't want to divide, so let's think this through. This is where the whiteboard would help, right? I need a piece of paper, sorry. So we have $100, which is 10,000 pennies. And if we apply a 10% tax to that, that's $10. We might not be able to do the tax piece about that. It might be too tricky. But let's stick with the simpler example, and maybe we'll come back to this. So let's say that we have quantity, right? Let's say int input. How many do you want? And then we say the total in pennies equals item price times quantity. Print. Let's just see if this works. So $50 and I want 3, I get 15,000, which is 150 times 100. So I can continue to do all this math, adds, subtracts, multiplies using integers. I can even do divisions by integers too if I want. And then at the very end of the program, then I can say total equals total in pennies divided by 100 and print the total. What happened?
It was doing this to me too. It makes you restart or refresh the page.
I don't want to lose my code. All right, let's try again. $53, so that I get my 1,500 and my 150. So this was important stuff years and years and years ago. Nowadays, computers have lots of memory and computers run very fast. Unless you're really working on tough stuff, you don't have to do some of these tricks. Okay. Any questions on this? Kind of bounced around a little bit. Is this helpful? Is this the kind of demoing type stuff you would like to see?
Yes.
Now that we spent 30 minutes on it.
Yeah,
Super helpful.
Okay, good. And I kind of bounced around a little bit. If I think about our lessons, right? We just covered the input stuff, which you'll get to in lessons 10. Not all of you have done that yet, right? Let's take a look at some of the other things. We've talked a lot about data types and variables. One thing that I'm going to show you since we're on the screen right now, because some of you said you're getting ready to look at the assignment here. There's a style guide right here. I'm going to park on the style guide for a minute. I'm going to bring it up. Share, new share. Okay. The style guide for a programming language is always going to be about rules and conventions. And you can think about that these exist, in other work that we all do. It's whether you use the Oxford comma or not, or 2 spaces after the period. Those are styles and conventions when you're, say, writing a paper. In programming languages, there tends to be a lot of style guides because there's basically an infinite amount of ways to do everything. And programmers tend to get pretty opinionated about the look and feel of programs. And if you're not careful, you're on teams where, you get basically the proverbial battle of, well, I like it this way and I like it this way. And, you're both wrong and we're going to do it this way. And it just ends up being a derailer. I would not be surprised if, some of you end up in internships or other things and you start to see this right away. So the rules around style guides is basically you have them as a set of requirements for a team to follow. And in most cases, we don't necessarily care about which style you use. We just care that we pick one and we're consistent. Okay. And so if I give you an example here, let's pick one of these here. These are good. I like these. Okay, you can see that what we're saying here is we're saying, hey, when you write mathematical operations, like adding 1 to I or doing this multiplication or whatever, always put spaces between your operators and your operands. And so, but there are definitely programs out there where the program always looks like this as long as it's consistent. So my request here is for you to make sure you read through these style guides, as you work on these programs. I used to be a big stickler for this in terms of following the style guide exactly. Nowadays, I'm more of a stickler of you being consistent, right? Like this one, for example, I don't care about. I tend to do the yes side on this almost regularly. Whereas this, I don't care, but in a program, I'll be consistent. So whichever one of these two you use, just be consistent. Does that make sense?
Yeah.
So take a look at the style guide. I think you'll find it useful. I can't promise that all the example code follows a style guide because it comes from different places. Right. And if I were to show you, 6,000 lines of C++ that I've written for an Arduino system, you'll see examples of things that look similar, but it's a different programming language. So, it might look different. But this is kind of the soft part of programming. And it's about avoiding confusion and making your code more documentable and shareable as you get into places where you're working in teams. Okay, oops, sorry, I didn't mean to do that. Let's go back to the lesson. Okay, so we looked at input, we looked at the style guide, we looked at data types. And earlier somebody said it was around the tax program. Was that 9, lesson 9?
Yeah.
Yeah, let's go to that one. Oh, so this is basically what we just did, right?
Yeah.
Same thing.
Right.
So we just did it in the other lesson, as we worked with that. So
right.
So now that we look at this code again, right? The difference here is we've specified the tax rate as basically as a read-only piece of data. in programming, it's called a constant. And the convention in Python is that we yell our constant names. We put them in all caps. And it's just it's a typical convention. And that's good because it helps. Oh, we lost somebody. It's good because you can scan this code here and you can see tax rate is a constant, and usually that stuff's up at the top of the code.
Is that pretty normal, is to have kind of all your general rules above your starting point, or does it matter?
Yeah. So if you call them rules, right? And they could be function declarations, they could be constants, they could be global variables, they could be libraries, they could be all sorts of stuff. And typically, if you have a super long program, you want to organize them in some way with good comments. But typically, you'll see constants above, basically above your main function, like shown here. And we could look at the style guide. The style guide probably specifies that, right?
So even like if I was in the middle of a code, like I understand you, Tim, like as you're going through, you're kind of like creating new things. Would you go back up above your code and like put that constant in there after you've written it into the code?
Yeah, and in fact, let's do that. Let's kind of pretend we're doing that.
Okay.
Okay, so let's say that we started from scratch and it's like, okay, we need to we're starting, I want to make sure my math is working. So I pick a cost value, I pick a tax value, and I run this program. Okay. And so if I want to test this, I grab my calculator, right? Or I put it in Excel and I say $10.24 at a 4.3 tax rate. I multiply that and then I add it back to the 1024 and I get my number and I go, okay, it looks like my math is working, right? And then I say, okay, well, this 0.043, this is a fixed number, right? So I'm going to go back up here and I'm going to say, tax rate equals 0.43. And then I might put a comment here. Actually, maybe I'll do, this is, this is specific tax rate for, state, whatever it is, right, that we have in here, right? And then I would change this to tax rate.
Gotcha.
Okay. Now, if I run my program, it should do the exact same thing, and it does, right?
Yeah. So
as you develop, it's always good. Sounds like my dog. It's a hilarious exact noise. As you develop, I always recommend kind of working your way inside out. Make sure a certain math thing works using known values, then add the input, then add the error checking, and so on, right? I do see problems where, students will write 100 lines of code before they test a single line of code, and then they hit run, and you get these stack trace errors, and even worse, you get what's called the silent data corruption bugs, right? Where the answer is wrong, but you don't even know until the very end. Those are the worst bugs to have. A trace error where it says bad job in red is a much better error to deal with because it's telling you that, right? So you absolutely can develop in that iterative way. And then, eventually you might have multiple tax rates and you might have to choose between the two tax rates, and you can continue to add on to this program by doing that. Does that make sense?
Yes, thank you.
Yep, you bet. This is we're kind of playing with pretty much the majority of what we cover in unit 3. We don't talk about conditionals, for example. A conditional is how do you make a decision based on the value of something? We don't get to that yet here. And I'm happy to show you, but we don't cover that yet. I just, before, as we're hitting the top of the hour here, I know some of you probably are on hard stops. I can stay a little bit longer. I want to see what other comments or questions anybody might have.
I have a question.
Sure.
In lesson 6, variables, I don't understand the assignment operators because there's a shortened syntax. And I don't understand how the syntax.
Are you talking about this one right here?
Yes.
Yeah. Okay. So, yeah, this is a good question. I could show you thousands and thousands of lines of code where I never use these shortened syntaxes. It's a convention that I've never used. But if you look, basically what it allows you to do is avoid entering the name of the variable a second time. So the rule here is whenever you want to change the value of a variable, you want to add something to it, you want to subtract something to it, you want to multiply something to it, and you only are, you're basically using that variable's value to create a new variable, a new value in that same variable, you can do this shortening, where basically what you do is you take the operator. So you take the operator that you're going to apply and you put it before the equal sign. Okay, so the fact that this doesn't assign the value 2 to num. This times equal basically says, basically take num, multiply it by 2 and put it back into num. And we can do that with any of the operators. As you look here, you can see in this table below, if you're finding yourself doing one of these, you can shorten it by doing these. And so let's do it. Let's well, this one doesn't have a replit. Okay, here we go. Let's just do it.
These are just like shortcuts, essentially.
It is. It's a shortcut convention here. So I'm gonna just totally change up this program here. All right. I'm gonna say a equals int value. Okay, so if I run this code, what did I do wrong? Where's my error?
You have to put input.
Thank you. By the way, this extra spacing here that I did here, legal, but not as readable. So I would fix it, right? All right, so there I enter 2 values and it adds them together. Okay, does this code make sense to everybody?
Yes.
Okay, so now instead of this, what I could do is I can do that convention and I can do that instead. 10-3, same answer. Okay, I personally think this is more readable than this.
Mm-hmm.
The computer treats them both identical. The bits that are generated by the compiler and by the replit interpreter, same thing. So one is not better than the other from a memory, a performance, or anything like that. This is purely a convention thing. And like we read up here, we go to here, it says here, we can shorten the syntax of the statement by using assignment operators. In code where we have single letter variables or variables like num or tax or item or whatever, there's really no point, to be honest. But instead of a, if this was, initial rainfall, Amazon day 1, right? Maybe it would be better to, maybe line 8 is better than line 7, right?
Yeah.
Maybe. I think it's a stretch, to be honest, my personal opinion. And if one of the other instructors were on, we might get into a debate, right? Because the other, one of the other instructors may be totally on the other end of this, and this, again, it's about style.
It's probably
So-
just also how long you have to write too. I mean, like you said, if you have 6,000 lines of code, it might be a little faster to do one over the other.
Yeah, maybe. I think maybe. And I think for me, I just never got, this convention, I just never started using it. So I don't use it.
Yeah.
So it's a good question.
I was wondering if you
Okay.
have any suggestions or resources on where we can do more practice on our own.
I do. Let me find. Let's take a look at this. Okay, this website, LeetCode, is a pretty fun achievement-based programming site. Let's see. Log in. So there's lots of challenges, and these challenges get quite difficult, and there's a lot of interview questions and things like that. But there's, if you go under this problem area, there are problems that are different difficulties. And you can see these ones with checks are ones I've done, right? So, so I've fiddled with this. But if we look at, let's look at this first one, the 2-sum. Okay, this is using arrays. Given an arrays of integers, basically you need to do some analysis. This is something that you don't know how to do yet, but something that you will learn by the end of the class. So this website is probably not for you on day 1 or day 10 here. It's more like halfway or 3/4 of the way through the class. I have another website bookmarked. Give me a second. I think it's called Practice Python. Give me 1 second. I'm looking. I think this may be it. Let's take a look at this one. So LeetCode is cool if you're not challenged as much as you want to be in this class. Take a look there, and you can see, we can connect on there, and you can do some of the ones that I've done or whatever. The other cool thing about LeetCode is you can write the programs in a bunch of different languages, and it has automatic testing and so on. Practice Python has some beginner exercises. Let's take a look at number 2, odd or even. And it's basically saying, ask the user for a number, depending on whether the number is even or odd, print out a message. This is something this is like one of the earliest programs you'll write to be able to test if a number is even or odd. We haven't done it yet, right? But I think we covered the concept.
Isn't it that the modulus?
Yes, yeah, modulus, yeah. Thank
It
you.
mentions that in the video, I think.
Lesson 8. Yeah, so lesson 8, this is remainders, right? So you think about, you learn remainders in elementary school when you learn division, and then you never deal with remainders for a long time. And it's kind of funny because remainders are pretty important in computer science, right? So if I want to know the remainder of 7 divided by 3, I can use this kind of apple thing, and it goes, the remainder of 7 divided by 3 is 1. Or in other words, 7 mod 3 is equal to 1. So we know how to do this in Python because we're showing it to you. What's missing here is checking to see if the number is even or odd. And if it's even, do something. If it's odd, do something else. You don't know how to do that yet, and you will soon. right? Those are called conditionals. Okay, so this practice Python is a good site for you to take a look at. I have one more, I think. Yeah, here it is. Coding BAT. Okay, so this has some example codes. It's got some warm-up problems. Let's take a look at that. No loops. This is also using conditionals, which you don't know yet. It's hard to write programs if you don't know how to test for things and make decisions based on the values of things, right? All we're doing right now is we're doing formulas and inputs and outputs. But here would be an example of basically, hey, given a number, if it's within 10 of 100, tell me yes, if not, tell me no, right? You'll know how to write a program like this pretty soon as well. So there's 3 sites for you to play with potentially. As you can see, what I was doing was I was just taking some of the sample code and I was saying, okay, well, what if I do this instead? What if I add this? What if I add a second name, or you know, instead of just name, I do first name and last name. Do that type of practice, and it'll build muscle memory, right? It will help you with the muscle memory, you know, of remembering, oh, this is where I use plus versus this is where I use int versus float and things like that.
Thank you.
Of course. Is that helpful? Those sites you think might be helpful?
Yes.
Yeah. Yeah, this leak code site is pretty interesting. If you find yourself getting in pretty heavy duty programming and you want to do like practice interview questions and things like that, you can go really deep. There's challenges and contests, and it's quite an interesting site. And so, you know, by the time you finish this class, you might start to dive in, and certainly after a second programming class, you'll be ready to dive even further in. What else?
I don't really have much more else. This has been very informative for, especially this chapter right now, gives me a lot to work on and continue to practice on. So I appreciate your time.
Yeah, you bet, of course. Yeah, our goal is to have these sessions Wednesdays and Saturdays, and you know, if you come to enough of them, you'll see all the instructors in theory, right? And you'll see members from other classes, you know, you get a chance potentially to interact with students and with the other instructors, and you know, might learn something that I'm not teaching, for example. So, any feedback that you hear from other instructors of something we should be doing in this class, let me know. And I did take that action on those discussion groups, and we'll think about what we might want to do different there. So, anything else from the team here? Anything else you'd like to cover? All right, sounds like a no. I will hang out for a few more minutes online here in case something does come up as you're, you know, deciding whether to log off or not. But otherwise, you know, thanks for all the cool questions, and we'll talk soon.
Thanks for your time, Jeff.
Yeah,
Have a
you
good night.
bet. You're welcome.
Thanks.
Absolutely.